Hi everyone, and welcome to this tutorial. My name is Mustafa, and in this tutorial I will show you how to create forward and remote SSH forwarding tunnels. I will use IMUNES to demonstrate that. So this tutorial will also help you if you are educator or trainer to demonstrate this concept and other networking concepts as well. So I'll just give an overview of the scenario and how we are going to make this forwarding connection, and then I will implement that on the network emulator. So for local forwarding, I will use now I created just a sample network. So this will be the local side of the network. So this side of the network is network A, and this is network B. So the client will be on this computer. So A1 will be the client. I will first make a SSH connection. So B2 will be the SSH server. So this is SSH server, and this is the SSH client. And now I will create a SSH connection from A1 to B2. Then in the first scenario, I will just forward local port 8080 on A1 through this connection to port 80 on host B3. So anything that, so let me use a different color. So anything that will connect to port 8080, it will be tunneled through this connection to port 80 on B3. Now the reason you might want to do that is when you have an insecure application. For example, a web server running on port 80. Usually this is the regular HTTP server with no SSL. Now with HTTP we can use SSL, but maybe for other applications like VNC, we can use the same concept to just secure the connection. So this is the SSH server, and in my topology I will make sure that B3 is not accessible from outside. So I will just make a firewall rule so that there is no possibility of doing a direct connection to B3. So the only way to access B3 is through the SSH tunnel. Okay, so let me use start IMUNES. Now IMUNES needs to be started as a super user so that we can run experiments. So I'll provide my password. Now if I need to use this window, I can just background this process. So Control Z and then just background, so that I can still have access to the terminal window if I need to. Now in the IMUNES, I want to create a network that looks like this one. So I'll just add, maybe just make 2 routers first. So and then I will rename them later. 2 switches, and then some hosts. So and then now the hosts and PCs are almost the same. I'll just I just use this these icons so that it's more it's clear that this host will be providing service. So there will be a server side, whereas the PCs with screens will normally be clients. So I will connect these hosts to each other. Sorry, I connect to the switch, and then from the switch I will connect. Now this looks cluttered. Let me just hide the IPv6 addresses, and I'll just rename them. So this A1, this A2, SA, RA, RB, B2, B3, and then B1. Okay, and then let me save this document, SSH forward. So maybe I can just adjust the layout so that the IP addresses are easier to read. Okay. Now, if you have started IMUNES as a normal user by mistake, you can still save the layout, but you will not be able to execute the experiment. So maybe you, in that case, you'll just close and then run IMUNES again as a super user. So now I think we have the topology almost identical to this one. So we can now run the experiment. Now on B3, I'll just double click to open a terminal. I will create a dummy server process using the netcat. So nc -l port 80, and then sorry -l listen, and then -p port 80. Now just to make sure that B3 is only accessible from inside, I'll just, on this router, I'll just add a firewall rule. So this is just simply a Linux host. So I will use the net filter IP table. So IP tables, and then add append to the forward chain for with the destination, anything that comes to the destination address 10.0.2.11. So I will just drop. So any packet that comes to this router with this destination address, it would be dropped. So effectively we have isolated this host from outside, so it can only be accessed from inside. And then I can test that here. So ping 10.0.2.10. I can ping it, but now 11 I cannot. So 100% packet loss. I cannot access B3 directly. And if I try to even use the netcat nc 10.0.2.11 port 80, so I don't get anything here. Okay, and then we can also see that these packets have been dropped. If I do IP tables -L -N -V, so you can see 8 packets has been dropped with this this rule in the forward chain. So I use the forward chain because this is acting as a router. Okay, now before I can establish SSH connection, I need to first enable the SSH service on B2. So services SSH start, and then because no passwords have been configured, I need to like generate SSH key. So SSH keygem. I just use the default values and without password, and then I just view using the cat command SSH, the home SSH IDRSA dot pub, the public part of the key. I just copy this, so I just select, and then using the right mouse button I copy, and then on B2 I just make directory under home SSH, and then just copy to the SSH authorized keys, append to that file, and just use the middle mouse button to just add the public key of A1, then Control D. So now, just to test that I can actually SSH to B2, so SSH 10.0.2.10. Yes, so I was able to log into B2. Now I will use the port forwarding. So now I want to forward traffic that comes to local port 8080 to port 80 on B3, and then the connection will be to B2. So I connect to B2 from A1 to A2 and tell SSH to forward anything that comes to port 8080 on the local side. So local to port 80 on the remote side. So remote. So this is the network on A1, SSH -L. So this is the local port 8080. Anything that comes to this port will be forwarded to 10.0.2.11, which is B3, to port 80. And then I specify the destination, the SSH server, which is B2, so 10.0.2.10. Okay, so now I have logged into B2. So notice anything I type here, it will be executed on B2. So if I want to access the A1 terminal, I just double click again to open another terminal, and just to confirm that I have a listening process here. So the socket stats minus, so to show the listening all TCP numerical values. So I can see that I have a listening process, so both for IPv4 and IPv6. So this is the one that's I'm concerned about. So I make sure it's working. Now on B3, I still have the listening process. I can use Wireshark to view the packets coming to B3 just to confirm that they will come from B2, not from A1. So I'll just filter using TCP just to show the TCP packets. So now I have this one, yeah, A1, and then B3. Okay, so now I will connect using netcat, so NC. Then I will use the local host, so 127.0.0.1, and then port 8080. So now I'll just connect. So I initiate a connection from A1 to itself. So a connection from A1 to A1 on port 8080. So now you can see that the three-way handshake connection has been established. And notice here that the source is 10.0.2.10. So this source address is actually B2. So the B3 sees this connection as coming from B2, not from A1. Okay, and now I can just let me hide this window. Now I can just test. So hello. So I can see that it appears here. So this packets actually appear on the server on Wireshark. Yeah. This is the content of the packet. So follow TCP stream, so I can see the packet here, packet payload, and I can also send reply. So hi. So as you can see, they are able to communicate, and all the traffic is going through this tunnel. So anything I send actually goes to B2 through the encrypted tunnel, and then it goes unencrypted from B2 to B3. Okay, so this has been the demonstration for the local forwarding. So I'll just close this connection, Control C. Now it has automatically terminated here. So I close all these, close the SSH connection, everything. Now I want to, I will, let me just, just restart. Yeah, I don't need that anymore. So now I want to show how to do a remote forwarding. Now remote forwarding, let me use a different color, just use a thicker line. So I want to make a connection now from A1 to B2, but this time I want to allow use this tunnel to forward from the remote side anything that comes to port 8080. So from B2 on port A. Let me just draw it. Undo. Okay, so it will be from B2 on B2 8080. So anything will come to the remote port will be forwarded through this tunnel to port 80 on A2. So even though I start the connection from A1, I will actually be redirecting traffic going to port 8080 on the remote side to a host on my local network. Now when I might need to do that. Now the most common case is when my network does not allow direct like remote connection. For example, if I am behind a network address translation, or even a double net, in that case it can be difficult to directly connect to a server on the local network. So I can connect to the remote network, and then I can allow a connection from that remote network through the through the SSH tunnel that I have created locally. So this is a case when we can use remote forwarding. Now for the remote forwarding case, I need to enable gateway ports on the B2 server. So I'll just edit the SSH config file on B2. So just echo gateway ports, yes, and then append it to the etc sshd config. And then I restart SSH restart. Now on A1 I connect SSH -R, and then I specify the listening should be on any IP address on port 8080, and then it will be forwarded to 10.00.10, which is A2 on port 80, and then I connect to B2 10.0.2.10. Now I'm B2. I can just confirm that it's listening, so ALTN. So now you can see that it's listening on all IP addresses on port 8080. So now I can just run a dummy server on A2. So nc -l -p80, and then I just open a Wireshark window. And then I just filter TCP traffic. Then I open a window at B1. I connect NC, and then I use the address of B2, so NC 10.0.2.10 port 8080. So now you can see here the connection has been established. The source is 10.0.0.20, which is A1, and then the destination is 10.0.0.10, which is A2. Okay, so now I have B1. I can just try to send any message. So hello, and then hi. So all the packets should appear on the Wireshark window. Okay, so you can see here that how remote forwarding works. So notice that in order to forward remote ports from other computers, I need to enable gateway ports on the SSHD configuration file. Okay, so I hope this tutorial has been useful, and thank you for watching.